The morning sun filters through the dense forest canopy as mountain man Jeremiah Stone examines the broken handle of his only axe. 3 days into the wilderness, hundreds of miles from the nearest settlement, his most essential tool has failed him at the worst possible moment. Winter is approaching fast, and without an axe, he cannot cut firewood, build shelter, or process game. His rifle is useless for these tasks, and his knife, while sharp, cannot handle the heavy work needed for survival in the mountains. But Jeremiah doesn't panic. He learned long ago that a true frontiersman never depends entirely on manufactured tools. In his mind, he carries the knowledge passed down through generations of mountain men, the ancient skills of creating functional tools from nothing but raw materials found in the wilderness. This knowledge separated the survivors from the casualties on the frontier. While greenhorns died when their equipment failed, experienced frontiersmen thrived by transforming rocks, wood, bone, and metal scraps into sophisticated tool systems that could sustain life indefinitely in the harshest conditions. The ability to create tools from scratch wasn't just a useful skill, it was the difference between life and death when you were weeks away from civilization and your survival depended entirely on your own ingenuity and knowledge. How did frontiersmen transform raw wilderness materials into functional survival tools? What techniques did they use to work metal without proper forges? Which natural materials provided the best raw materials for tool construction? And how did they create complete tool systems that could replace everything they might lose or break in the wilderness? Today, we're exploring the ingenious methods that frontiersmen used to build survival tools from nothing. Techniques that turned the wilderness itself into a hardware store for those who knew how to read its resources. Stone Tool Mastery. Turning Rocks into Precision Instruments, 1800 to 1830. Jeremiah kneels beside a creek bed, his experienced eyes scanning the water-worn stones for the telltale signs of workable flint. After 30 years in the mountains, he can identify good tool stone at a glance. The fine grain, the way light reflects off fresh breaks, the sound it makes when struck. Stone tool making was the foundation of all frontier tool craft, the skill that every mountain man learned first because it required no materials except what could be found on the ground. When everything else failed, a man who could knap stone could create cutting tools, scrapers, and points that would keep him alive indefinitely. The stone selection process was critical for successful tool making. Not all rocks were suitable for tool construction, and frontiersmen learned to identify the specific types of stone that would produce sharp, durable edges. Flint, chert, obsidian, and quartzite were the preferred materials, each with different working properties and applications. The knapping technique development required years of practice to master. Frontiersmen learned to control the force and angle of their strikes to produce predictable flake patterns, creating tools with specific shapes and edge characteristics. The basic technique involved striking a core stone with a hammerstone to remove flakes that could be shaped into tools. The pressure flaking refinement allowed for precise edge shaping and sharpening. Using antler tines, bone points, or hardwood tools, experienced knappers could remove tiny flakes to create razor-sharp edges and specific tool shapes. This technique was essential for creating arrowheads, knife blades, and specialized cutting tools. The tool type specialization produced different implements for specific tasks. Scrapers for hide processing had different edge angles than cutting knives. Drilling tools required pointed tips and sturdy construction. Each tool type demanded specific knapping techniques and stone selection criteria. The hafting and handle construction transformed stone blades into functional tools. Frontiersmen learned to create secure attachments using sinew, rawhide, pine pitch, and wooden handles. The hafting technique was often more challenging than creating the stone blade itself, requiring precise fitting and strong, flexible bindings. The maintenance and resharpening techniques kept stone tools functional over extended periods. Unlike metal tools, stone implements could be resharpened in the field using simple pressure flaking techniques. Experienced users could maintain stone tools indefinitely, creating new edges as old ones dulled or chipped. The heat treatment process improved stone working properties and tool performance. Certain stones could be heated in fires to alter their internal structure, making them easier to knap and producing sharper, more durable edges. This technique required careful temperature control to avoid cracking or ruining the stone. The composite tool construction combined stone elements with other materials to create sophisticated implements. Stone blades could be set into wooden handles with bone or antler reinforcements, creating tools that were stronger and more versatile than simple stone implements. The specialized applications included tools for specific frontier tasks, stone scrapers for hide processing, drilling tools for making holes in leather and wood, cutting implements for food preparation, and weapon points for hunting and defense. Each application required different stoneworking techniques and tool designs. The quality control methods ensured that tools would perform reliably under harsh conditions. Frontiersmen learned to test stone tools thoroughly before depending on them, checking for hidden flaws, weak points, or poor hafting that could cause failure at critical moments. The raw material procurement involved understanding where to find suitable stone in different geographical regions. Frontiersmen learned to identify geological formations that produced good tool stone and to recognize the signs of ancient quarry sites where previous peoples had extracted stone for tool making. The teaching and knowledge transfer ensured that stone tool-making skills were passed down through generations of mountain men. Experienced craftsmen taught newcomers the subtle techniques of stone selection, knapping, and tool construction that could mean the difference between survival and death in the wilderness. By 1830, stone tool-making had become a refined art among frontiersmen, representing thousands of years of accumulated knowledge adapted to American wilderness conditions. These skills provided a foundation of tool-making capability that could sustain life even when all manufactured equipment was lost or broken. Metal working without a forge, improvised blacksmithing in the wild, 1830 to 1860. The broken axe head lies before Jeremiah like a puzzle waiting to be solved. The handle has snapped, but the metal head is still sound. Valuable iron that represents weeks of work if he had to start from raw ore. But he doesn't need a proper forge to work this metal. He needs only fire, stones, and the techniques his grandfather taught him for field blacksmithing. Improvised metalworking was one of the most valuable skills a frontiersman could possess, allowing him to repair, modify, and create metal tools using only materials available in the wilderness. These techniques could restore broken equipment to full functionality and create new tools from scrap metal found in abandoned camps or settlements. The fire construction for metalworking required understanding how to create and maintain the high temperatures needed for working iron and steel. Frontiersmen learned to build specialized fires using hardwood charcoal, forced air from improvised bellows, and fire pit designs that concentrated heat effectively. The bellows improvisation used natural materials to create forced air systems that could reach blacksmithing temperatures. Leather bags, hollow logs, and even animal bladders could be converted into bellows systems that provided the consistent airflow needed for hot metal working. The anvil substitution techniques used rocks, logs, and other hard surfaces as anvils for shaping hot metal. The key was finding surfaces that were hard enough to resist deformation, but positioned correctly for effective hammering. Large rocks with flat surfaces were preferred, but hardwood stumps could work for lighter operations. The hammer creation involved making effective hammering tools from available materials. Rocks could be hafted as hammers, but the best improvised hammers were made from pieces of iron or steel found in the wilderness. Even broken tools could be converted into effective hammering implements. The heating and temperature control required understanding how to heat metal evenly and to the correct temperature for different operations. Frontiersmen learned to judge metal temperature by color and to control heating to avoid burning or weakening the metal during working. The basic forming techniques included drawing out metal to make it longer and thinner, upsetting to make it shorter and thicker, and bending to create specific shapes. These fundamental operations could be performed with improvised tools and allowed for extensive modification of existing metal pieces. The joining and welding methods used traditional blacksmithing techniques adapted to field conditions. Forge welding could be accomplished with improvised equipment, allowing broken pieces to be rejoined or different pieces to be combined into new tools. The hardening and tempering processes improved tool performance and durability. Frontiersmen learned to heat-treat steel tools to achieve the proper balance of hardness and toughness for different applications. This required precise temperature control and understanding of cooling rates. The tool modification techniques adapted existing tools for new purposes. A broken knife could be reshaped into a scraper, a damaged axe head could become a hammer, and worn-out tools could be converted into raw material for new implements. The repair methodologies restored damaged tools to full functionality. Cracked handles could be reinforced, dulled edges could be resharpened, and broken parts could be welded back together. These repairs often made tools stronger than their original construction. The scrap metal utilization involved finding and using metal from abandoned equipment, broken tools, and natural iron deposits. Frontiersmen learned to recognize valuable metal and to assess its suitability for different tool-making applications. The safety considerations prevented injuries during improvised metalworking. Working with hot metal and improvised tools created unique hazards that required careful attention to safety procedures. Burns, cuts, and eye injuries were constant risks that had to be managed carefully. The quality assessment ensured that improvised metalwork would perform reliably under frontier conditions. Frontiersmen learned to test their work thoroughly and to identify potential failure points before depending on repaired or modified tools in critical situations. By 1860, improvised metalworking had become a standard skill among experienced frontiersmen, allowing them to maintain and create metal tools far from civilization. These techniques represented the adaptation of traditional blacksmithing methods to wilderness conditions and provided essential capabilities for long-term wilderness survival. Wood and bone tool construction, crafting functional implements from organic materials, 1860 to 1880. With his metal tools restored, Jeremiah turns his attention to creating the specialized implements he needs for daily survival tasks. Wood and bone offer abundant raw materials for tool construction, and the techniques for working these materials can produce tools that are often superior to metal implements for specific applications. Organic material tool making represented the largest category of frontier tool construction, providing everything from handles and hafts to complete implements that could perform sophisticated tasks. The abundance and workability of wood and bone made these materials essential for wilderness tool making. The wood selection process required understanding the properties of different tree species and how they related to tool performance. Hardwoods like oak, hickory, and ash provided strength and durability for handles and structural components, while softer woods like pine and cedar were easier to work and suitable for different applications. The seasoning and preparation techniques ensured that wooden tools would remain stable and functional over time. Green wood was easier to work but would shrink and crack as it dried. Frontiersmen learned to select properly seasoned wood or to season wood quickly using controlled drying techniques. The shaping and carving methods used simple tools to create complex wooden implements. Knives, axes, and improvised cutting tools could shape wood into handles, bowls, containers, and specialized tools. The key was understanding wood grain and working with it rather than against it. The joint construction techniques created strong, durable connections between wooden components. mortise, and tenon joints, lashing with sinew or rawhide, and wooden pins could create assemblies that were stronger than the individual components. The bone tool creation utilized the skeletal remains of hunted animals to create specialized implements. Bones provided hard, durable material that could be shaped into awls, needles, scrapers, and cutting tools. Different bones had different properties and applications. The antler working techniques took advantage of the unique properties of deer, elk, and moose antlers. Antler was harder than bone but easier to work than stone, making it ideal for pressure flaking tools, handles, and specialized implements that required both strength and precision. The handle and haft construction created secure attachments between tool heads and handles. The fit between handle and tool head was critical for both performance and safety. Frontiersmen learned to create tapered fits, reinforced joints, and flexible lashings that could withstand heavy use. The specialized tool creation produced implements for specific frontier tasks: wooden bowls and containers for food preparation and storage, bone needles for sewing and leather work, wooden handles for stone and metal tools, and composite implements that combined multiple materials. The finishing and protection techniques improved tool durability and performance. Sanding with abrasive stones, oiling with animal fats, and heat treatment could improve the surface finish and longevity of wooden and bone tools. The maintenance and repair methods kept organic tools functional over extended periods. Wooden tools could be reshaped and refinished, bone tools could be resharpened, and damaged components could be replaced or reinforced as needed. The composite construction combined wood, bone, stone, and metal into sophisticated tool systems. These composite tools often performed better than implements made from single materials, taking advantage of the best properties of each component. The preservation techniques protected organic tools from decay, insect damage, and environmental degradation. Proper storage, protective coatings, and regular maintenance could extend the life of organic tools significantly. The innovation and adaptation allowed frontiersmen to create new tool designs based on specific needs and available materials. The flexibility of organic materials made it possible to create custom tools that were perfectly suited to individual requirements and local conditions. By 1880, wood and bone tool construction had reached a high level of sophistication among frontiersmen, representing the culmination of centuries of traditional crafting knowledge adapted to American wilderness conditions. These techniques provided the foundation for creating complete tool systems from renewable natural materials. Complete tool system integration, building self-sufficient workshop capabilities, 1880 to 1900. Jeremiah steps back to survey his work. In 3 days, he has transformed a collection of raw materials into a complete tool system that can handle any task the wilderness might demand. His improvised workshop can now produce, maintain, and repair tools indefinitely, making him truly self-sufficient in the deepest wilderness. The integration of different tool-making techniques into complete systems represented the highest level of frontier craftsmanship. Master tool makers could create workshops that were entirely self-sustaining, capable of producing and maintaining every tool needed for wilderness survival. The workshop establishment involved creating a permanent or semi-permanent base where tool-making activities could be conducted efficiently. This included fire pits for metalworking, work surfaces for carving and assembly, and storage areas for raw materials and finished tools. The tool hierarchy development prioritized which tools to make first and how they supported the creation of more sophisticated implements. Basic cutting tools enabled the creation of handles and hafts, which in turn supported the construction of more complex composite tools. The raw material stockpiling ensured that tool making could continue regardless of seasonal availability or local scarcity. Frontiersmen learned to collect and store stone, metal, wood, bone, and other materials when they were abundant for use during times of scarcity. The production planning organized tool-making activities for maximum efficiency and effectiveness. Understanding which tools were needed most urgently which materials were required for different projects, and how to sequence work to minimize waste and maximize productivity. The quality control systems ensured that all tools met the standards required for reliable wilderness use. This included testing procedures, inspection criteria, and standards for materials and construction that would prevent tool failure in critical situations. The maintenance scheduling kept all tools in optimal condition through regular inspection, sharpening, repair, and replacement. A systematic approach to tool maintenance prevented the accumulation of small problems that could lead to major failures. The innovation and improvement processes allowed toolmakers to refine their techniques and develop new solutions to wilderness challenges. Experienced craftsmen continuously improved their methods and shared innovations with other frontiersmen. The teaching and knowledge transfer ensured that tool-making skills were preserved and passed on to new generations of wilderness dwellers. Master craftsmen took responsibility for training others in the essential skills of wilderness toolmaking. The specialization development allowed different individuals to focus on particular aspects of tool-making while contributing to the overall capability of frontier communities. Some became expert stone knappers, others specialized in metalworking, and still others focused on organic material construction. The trade and exchange systems allowed frontiersmen to obtain tools and materials that they could not produce themselves. Trading networks developed around tool-making specialties, allowing for the exchange of finished tools, raw materials, and technical knowledge. The adaptation to local conditions modified tool-making techniques to take advantage of regional resources and address specific environmental challenges. Different geographical areas required different approaches to tool-making based on available materials and local conditions. The emergency capabilities provided backup systems for tool-making when primary methods were not available. Emergency techniques could produce basic tools quickly when survival was at stake, even if the results were not as refined as tools made under optimal conditions. The legacy preservation documented and maintained the accumulated knowledge of frontier toolmaking for future generations. Written records, teaching traditions, and preserved examples ensured that these essential skills would not be lost as the frontier era ended. A man with good tools and the knowledge to make more is never truly helpless in the wilderness, wrote mountain man Samuel Bridger in 1887. The forest provides everything needed to sustain life, but only for those who know how to transform its gifts into the implements of survival. The tool-making capabilities developed by frontiersmen prove that with knowledge, skill, and determination, it's possible to create sophisticated tool systems from nothing but raw, natural materials. These techniques represent the ultimate in self-sufficiency and demonstrate that human ingenuity can overcome almost any challenge when backed by traditional knowledge and practical experience. The legacy of frontier tool making extends far beyond its historical importance. In an age of increasing dependence on complex technology and global supply chains, the ability to create functional tools from basic materials represents a valuable form of resilience and independence that remains relevant today.